Today, I would like to share with you two books that I think they can help you in math foundation courses in computer science. First up, How to Read and Do Proofs by Daniel Solo. First highlight, intuition. Okay, this is how Professor Solo illustrates the process tackling a proof. What? How come a maze has anything related to proofs? Let me show you. Let's take this classic proposition as an example. If the right triangle XYZ with sides of lengths x and y and hypotenuse of length z has an area of z squared over 4, then the triangle XYZ is isosceles. Tackling a proof is typically like this. You have something at hand and you want to reach out to the destination as well. This is just like going from A to B or from B to A. What do we have? We know that the area of the triangle is z squared over 4. Besides this example, we also know that the area of the triangle is base multiple height divided by 2. Then that would be xy over 2 and it's equal to z squared over 4. Multiply 4 on both sides, we got something nicer. By Pythagorean theorem, we also know that x squared plus y squared equals z squared. Use this expression to subtract the previous one, we got this. It's a perfect square trinomials, and we know that it's equivalent to this. At this point, we somehow don't know where to go. You start from A and try and go to B. You hesitate what's doing next. Then you can change your mindset, start from B and go backward to A. B is what we need to prove that the triangle XYZ is isosceles. Then by isosceles, it means that x equal y. From x equal y, we have this, and square both sides, we have this. When the path is connected, it means you can go all the way from the antecedent to the consequent forward. A can find B, and B can find A. That's the forward and backward. Second highlight, reading and doing proof like common English sentence. Suppose you need to prove this theorem. If n is an even number, then n squared is even. You will not write proof like this, as it is difficult to understand and way too abstract. Rather, reading your proof is just like reading English sentence, elegant like poem. Every sentence makes sense and nicely related to each other. Third highlight, practical exercise with solutions. In this book, Professor Solo provides many exercises to get your hands dirty. You can go to the www.wiley.com/college/solo for the solutions and lecture videos. Next, let's explore Michael Sipser's Introduction to the Theory of Computation, and his book has online lectures on MIT OCW. The goal of this book is to answer one question. What are the fundamental capabilities and limitations of computers? To answer this question, this book focuses on three areas of theory of computations: automata and languages, computability theory, complexity theory. When you're reading this book, Professor Sipser keeps enforcing the big picture of each topic. In the meantime, each section has an easy to hard learning curve, which provides a great experience. Let's take the section of non-determinism finite automaton as example. It starts with the big idea and big picture as we mentioned before. So we know that non-determinism finite automaton is related to the theory of computation. When we start learning a new subject, we're not familiar with the term and definition. So when I say non-determinism finite automaton, it sounds difficult to understand in English already, but Professor Sipser said non-determinism may be viewed as a kind of parallel computation where multiple independent processes or threads can be running concurrently. Oh, that's some words I'm familiar with. After giving this intuition, Professor Sipser gives a simple example on NFA. It looks like throwing a trail of inputs like 0, 1, 0, 1, 1, 0 in parallel and see which one is accepted. With intuition and example in mind, a formal definition will not be that scary anymore. Then comes the hardest part, the proof of this definition. But we always have a proof idea ahead of each proof, so you know the skeleton and strategy of the proof. I really enjoyed this easy to hard progress. That's it. I hope you like it. I'll see you next time.